Hello everyone, welcome back to another video of our multi-threading in Java series. In this video, we will be looking into different types of thread pools that exist within the Java Executor service. So the first type of thread pool is fixed thread pool. This pool has a fixed number of threads, and as the tasks come in the pool, it is picked up by the threads one by one. So first task came, it is picked up, second task picked up, third task picked up, and so on. 10 tasks are picked up by this thread pool, correct? Now if the number of submitted tasks exceeds the number of threads, then these extra tasks are held in an unbounded queue until a thread becomes available, right? So if the 11th task comes, it will be stored here until one of these thread becomes free. Now suppose as soon as thread 0 completes execution of T0, it can go ahead and pick the next task from this queue, right? So very simple. Now one more property is, so the threads in the pool are never destroyed until and unless the pool is shut down, correct? For example, you can take an analogy of a small restaurant kitchen having exactly 4 chefs. So if 4 customer orders arrive, each chef takes one order, right? Now if the 5th order arrives, it goes into a waiting ticket rack, right? If 6th order arrives, it goes inside this waiting queue, correct? And so on until one of the 4 chefs finishes their current dish. As soon as they finish, they can pick up new orders from this queue, correct? And the total number of chefs never changes, ensuring a controlled and predictable level of service. Now let's see how do we write code for it. So to create our fixed thread pool with fixed number of threads, what you do, you use new fixed thread pool methods from the executors class, right? So you use executors.new fixed thread pool, and the number of threads that you want in the pool is 2, correct? So you write 2 here. Suppose you are submitting 5 tasks in that thread pool. How do you submit task? By using the execute method. What is the task that you are submitting? The task is, you are just printing the task ID and then the task started by thread name, correct? Now you are simulating the work by making the thread sleep for 2 seconds, and after that you are ending that task by printing task finished by thread, whatever thread name is, correct? So let's go ahead and execute it. And one more thing, at a time only 2 tasks will be executed in parallel, correct? So if we run it, right, 2 tasks, correct? Then 1 has finished, 3 has started, 2 has finished, 4 has started, right? And only 2 threads are used in executing all these tasks, correct? So if you see at any point of time, if suppose I take this, the difference between started and finished should be either 2 or less than 2, correct? So if I take this point of time, so 1 was started, then 1 was finished, and at present 2 tasks, task 2 and task 3 are started, correct? If I take this point of time, then 3 started and 2 finished. 1 has finished, 2 has finished, and only task 3 is being executed at this point of time, correct? So this was very simple, the fixed thread pool. Now the second type of thread pool is cached thread pool. Now this pool is unbounded and it dynamically adjusts its size, right? So what does it mean? So suppose there is one task T1 initially. At that point of time, only one thread will be created initially. Okay, so this cached thread pool starts with just one thread. If one task comes, that task is given to thread 2, correct? Now suppose second task comes. When second task comes, first it is checked whether the previously created thread 1 is free or not. If this thread is not idle and still executing task T1, then another thread will be created and this task will be assigned to this thread, correct? Now suppose T3 comes, T3 also checks, T1 is busy, T2 is busy, so let's go ahead and create another thread, thread 3. T4 comes, it sees thread 1 is busy, 2 is busy, 3 is busy, and again a new thread is created. Now suppose at the time when task 5 T5 arrives, at that particular point of time, thread 1 completes the execution of task 1. So thread 1 is idle. Therefore, a new thread will not be created and task 5 will be assigned to thread number 1, correct? And also one more thing, Suppose if task 5 wouldn't have come, thread 1 has executed the execution of T1 and it has been waiting for more than 60 seconds, right? If that is the case, then that particular thread which sits idle for 60 seconds, that thread is killed, right? So if a thread remains idle for a specified time, which is usually 60 seconds, then those are terminated and removed from the pool. Correct? Now let's see the code for CachedThreadPool. So to create a CachedThreadPool, all you have to do is write executors.new CachedThreadPool. You do not define any number of threads in this because it is dynamically managed by the number of tasks that are provided to this thread pool. Correct? So for example, suppose you are submitting 30 tasks to this thread pool. So if you are submitting 30 tasks, let's see how many number of threads can manage the execution of these 30 tasks, right? So if I run this and see, what is the max number? Thread 13. Yes, so 13 threads were used to execute 30 tasks, right? Now if I stop this and rerun, you will get a different number. This time how many threads were used? This time 16 threads were used to execute 30 tasks. Correct? For analogy, you can take an example of a consulting agency that hires freelancers. Correct? So when a big project arrives and no freelancer is free, the agency immediately hires a new one. Correct? And when a project is finished, the freelancers are kept on standby. And if the freelancer sits idle for over a day or 2 days, then they are let go or terminated to save the cost that company occurs, right? So the pool size constantly grows and shrinks based on the immediate demand of the task that we have, correct? So this is about the CachedThreadPool. The third type of thread pool is SingleThreadExecutor. Correct? Now this pool uses only a single worker thread to execute tasks. The guarantee here is the task will be executed sequentially in the order they were submitted. Correct? So it provides a queue to store all these tasks. The single worker threads picks up task one by one from the queue and executes it sequentially. Correct? Now, if this thread pool unexpectedly terminates, suppose it has completed task 1, task 2, task 3 and then it terminates, correct? Then automatically a new thread is created by OS which replaces it and continues the execution from where the previous thread has left. So it will go ahead and execute task 3 and then task 4, correct? For example, take an analogy of a single network printer. So every print job is a task which is submitted to the printer's queue, right? The printer must complete one document before it moves on to and start printing the other one, correct? So this ensures sequential order. Now if the printer jams and it needs a reboot, right? So a new identical printer is immediately swapped to continue the processing of whatever documents that are remaining for printing, correct? Let's see code example for this. So to create a single thread executor, you use new SingleThreadExecutor method from the executors class, correct? So here also you don't have to pass any parameter because it only has one thread to execute all the tasks, correct? So what we are doing, we are passing 3 tasks to this single thread executor. So it will be executed sequentially, correct? First task 1, then task 2, then task 3. Let's go ahead and run it. Task 1 is executing. As soon as it is completed, 2 started. As soon as 2 completed, 3 started and then 3 completed, correct? Now see, if instead of new thread executor, what if I write new FixedThreadPool and I pass a parameter 1 and then I go ahead and run this, what will be the output? Task 1 completed, then task 2 completed, then task 3 completed, correct? So irrespective of whether I write new FixedThreadPool or I write new single thread executor, order will be sequentially only, right? Then what is the difference? So the difference is if you use new single thread executor, then this ensures that even if your active thread encounters a fatal exception or stops, then a brand new worker thread will be created to process the remaining tasks which are present in the queue. But when you use new FixedThreadPool, with one thread, what happens if a single worker thread terminates due to unexpected or unhandled exception, then at that time no new thread will be created to replace it, right? So the pool will be unable to execute any further tasks even if the task remain in the queue, correct? So that is the difference. That is why you use new single thread executor, correct? Now the fourth type of task is scheduled thread pool. Now this scheduled thread pool executor is a specialized implementation of the executor service that allows you to schedule tasks to run after a certain delay or to execute it periodically, right? So it acts similar to an alarm clock or calendar or reminders on your phone, correct? So it is primarily used for timing related or background maintenance or recurring tasks, right? So these are the three different ways, three different methods which you can use and schedule your task. So let's see all these methods one by one in our code, right? So here we are using only one thread for simplicity, and this is the simplest form where a task is run exactly once after a specified delay. Right? For that we use schedule method. What this schedule method does? So this schedule method schedule the task. What is the task? This is the task. Task executed after 5 seconds, right? So this is what this task has to print. Now what are these two parameters? This is the delay parameter. So this says before executing this task, wait for 5 seconds and then execute it, right? This is the time unit that we have passed. Right, so if I go ahead and execute this and I will count till 5, so after 5 seconds only this line will be printed because initial delay we have kept is of 5 seconds, right? So 1, 2, 3, 4, 5. Task executed after 5 seconds, correct? And this task will only be executed once. Very simple. Execute a task once after a certain delay. That's what schedule method does. Now the second method is schedule at fixed rate. Now this type of scheduling is called fixed rate scheduling, correct? So if I go ahead and see what is there in this example. So what happens here is the task runs repeatedly with the time between the start of one execution and the start of next being a fixed period. What do I mean by this? Let's see on our blackboard. For schedule at fixed rate, suppose you have a task that gets executed in 5 minutes, correct? And you want to execute this task after a fixed rate of every 10 minutes, correct? Suppose this is your timeline. This is 10 o'clock, 10:10, 10:20, 10:30, 10:40 and so on, correct? So initially when you execute this task T, it will take 5 minutes to be executed, right? Now what is the rate at which we have defined this task to be re-executed? It is 10 minutes, right? So these 10 minutes will be counted from the start of this task, right? And 10 minutes from that, correct? So this task will be re-executed at 10:10, correct? Again it will take 5 minutes, correct? What is the rate? 10 minutes. Again from the starting point of the last tasks, we will take it. We will count 10 minutes. It is 10:20, correct? So after a fixed interval of 10 minutes, it will keep on executing and it will take 5 minutes to execute, correct? Now, what if the task takes 15 minutes to complete? What happens then, correct? So then this is 10 o'clock. This is 10:10. 10:20, 10:30, correct? Now we have kept our rate to be executed at 10 minutes. After every 10 minutes this task needs to be executed, but the task itself takes 15 minutes to execute, correct? So what will happen? So at this point of time, task will start executing. It will go ahead and execute till 10:15, correct? 15 minutes are completed. Now since the task was already executing, it will not be started at 10:10 even though the rate is 10. But as soon as this task is completed, another instance of the task will be executed. Why? Because it was scheduled to run at 10:10, but task itself was running at that time, so it will wait for the task to complete it and immediately it will start the execution of the same task again, right? So it will keep on executing till 15 minutes, 10, 15, 25 till 10:30 it will keep on executing, correct? And after that again a new instance of this task will be created and it will run for 15 minutes, correct? Let's see this in action in our code. So what I have done here, so our task take 3 seconds to complete, correct? And initial delay is 0, so it will start immediately, and the period of execution is 5 seconds, correct? So what it will do, initially this will be printed, then after 1, 2, 3, after 3 seconds this task will be completed, and then 4, 5. In the next 2 seconds again a new instance of this task will be created and it will run, and again this will be printed. Let's go ahead and run this and see whether this happens. 1, 2, 3, task end. 4, 5, new task. 1, 2, 3, task end. 4, 5, new task, correct? So this is how it keeps on executing at fixed rate. Now the next function is schedule with fixed delay, correct? So if I go ahead and comment this and uncomment our third example, what happens here? Here the task runs repeatedly with a fixed delay, but that delay is inserted between the completion of one execution and the start of the next execution. So what do I mean by this? So here what happens, if you have this timeline, suppose your task take 5 minutes and rate is 10 minutes. This is 10 o'clock, 10:10, 10:20, 10:30 and so on, right? So the task will be executed. It takes 5 minutes to complete, correct? Now this 10 minutes, the rate will not be counted from the starting time. It will be counted from the ending time of this tasks, correct? So after this again it will wait for 10 minutes and then the new instance of the task will be executed, right? So 5-minute execution, post that 10 minutes will be waiting time. So at 10:15 a new instance of this task will be executed and it will again take 5 minutes to execute, right? So after 10:20 again 10 minutes of waiting time since the rate is 10, and then another instance will be executed, correct? So in schedule at fixed rate, the starting point of multiple executions were taken into account, but here the ending point of the last execution will be taken into account to calculate the time for which the scheduler has to wait, right? So let's go ahead and see this in code. So in our code, what have we done? Same thing. Same example here, just we are using schedule with fixed delay. So what will happen? Initially this will be printed. After 1, 2, 3 seconds this task will again end. After that 4, 5, 6, 7, 8. After 5 seconds again this task will be executed, correct? So if I go ahead and run this, correct? Task end 1, 2, 3, 4, 5, correct? 1, 2, 3, task finish. 1, 2, 3, 4, 5, correct? Now task has again started. So if I go ahead and if you see this, the starting of first task, the ending of first task and the restarting of the same task, if you subtract this is approximately 5000 milliseconds, which is equal to 5 seconds, correct? Again, this difference between the finished and starting is 5 milliseconds, correct? And similarly, I forgot to show for the previous one. If you see here, if I comment this, right, and I run this, right? So if you see, so the first starting of this task and second starting of this task, if you subtract this is approximately 5000 milliseconds, which is 5 seconds. Again 73838 minus 78839, approximately 5000 millisecond, 5 seconds, right? So starting difference is 5000 milliseconds, and in fixed delay, starting ending, the difference was 5000 milliseconds, correct? Now the fifth type of pool is work stealing pool. Now this pool was introduced in Java 8, and this pool uses fork join framework and is based on work stealing algorithm. Now what is work stealing algorithm? For analogy, imagine a group of specialized assembly line workers working in parallel, correct? Now each worker has their own small queue of parts to assemble. Now if one worker finishes their queue and sees that another worker's queue is piling up, then what they can do? They can steal the task from this worker's queue to help this worker out, correct? So they have minimized the load from the other worker and at the same time kept itself busy. So this dynamic work stealing mechanism, what it ensures? It ensures that all cores are kept busy and maximizes the CPU utilization for large and parallel problems, correct? When one core is piled up with task and another core is empty, then the empty core can pick up the task from the piled up core and execute it, right? So it has stole the task from another core, and that is why it is known as work stealing pool. Now, one of the most important thing is this work stealing queue, it maintains the number of threads which are equal to the number of processor cores that we have in our system. Let's see this in our example. So if I show you this, we only write executors.new work stealing pool. So this laptop on which I am running, this has 12 cores, correct? So what it will be printed? Submitting 30 tasks to work stealing pool and the number of processors that we have, and that will be equal to 12. So 12 will be printed. Now we are giving 30 tasks to be executed by this thread pool. We'll see in our output that at max 12 threads are created for 12 different processors to maximize the processing. Now how do they steal between them? That we won't be able to simulate, but at least we'll be able to see that the number of threads created are equal to the number of cores that we have in our system, correct? So let's go ahead and run this. Correct? When I run this, you can see submitting 30 tasks to 12 cores. And what is the max number of worker that we have created? Correct? So the max number is 12, correct? 12. So at max 12 number of threads was created, and that thread is equal to the number of cores that we have. And it follows stealing mechanism, work stealing mechanism that I just showed. These were all the different types of thread pool that we have in Java. Correct. So that's it for this video. I hope you are clear with the types of thread pools that Java have. And until the next video, stay safe, stay healthy. Bye bye.